Hey, good morning, good afternoon, Algebra 2 classes. Make sure this is the Algebra 2 class that's watching this video. So we're going to get started here in just a second on lesson 2.1. My paper people, if you have not already passed 2.1 out, can you go ahead and pass those out? They're in the back in the folders, just where you would normally find any other assignment. Make sure you get lesson 2.1 notes. And then after that, we can go to... we can pass out the homework once we're done with this. Before I even start this, I'm going to tell you, I'm sure I'm going to make mistakes. I hope the sound sounds okay. I hope everything is well. And I hope you guys miss a few days of school, but I probably will make mistakes. Just try to, if I make a mistake, like on a math, just kind of be patient with me. Hopefully this helps. I think it beats busy work, because it allows us to move forward, and we need to move forward with our lessons. So, hey, I can't be there with you all this week, but I will enjoy my time at this conference. And like I said, I appreciate your patience and your help throughout this. So if I say something wrong, someone just be like, hey, he meant 8, or, if I make a mathematical error, just putting that out there, just not to make this, a roast fest on Mr. IPOC. So, let's get started on lesson 2.1. So a function is a quadratic function. So it is a quadratic function. If its equation can be written in the form f of x equals ax squared plus bx plus c. With a not equaling 0. Okay? All quadratic functions are transformations of a parent function. You all are familiar with x squared, x cubed, and the absolute value of x. The graph of a quadratic function is what we call a parabola, and you know that. So really what we're looking at when we're talking about quadratic, we're talking about an x squared as our leading term, or in this form, ax squared. So what we're actually going to discuss today is actually the vertex form of a quadratic equation. So see, there's my first mistake already. Make sure you put a little m in there. I'm sure there's other mistakes in the notes, but that's okay. The vertex form of a quadratic function is f of x is equal to a times x minus h squared plus k. So f of x equals a times x minus h squared plus k. Now that may look a little bit weird to you, but that is actually something we have already went over. I just have not presented it as vertex form. If you can recall, f of x equals x squared. You know what that is. You know what the graph looks like. Then we went to f of x equals x squared plus 2. A vertical translation of 2. Then we went to a horizontal translation, and it looked like this: x minus 2 squared plus 2. So the horizontal translation to the right 2 and then up 2. And then we added stretches and shrinks by putting something on the outside. 3 times x minus 2 squared plus 2. So if you notice, this is where we were graphing at the end of chapter 1. This is where we're at. So chapter 2, we actually explained this is actually a form. It's called vertex form. Okay? So vertex form is, as I just mentioned, I'm going to rewrite it here. F of x is equal to a times x minus h squared plus k. Where a actually determines, if you think about what a over here, what this 3 was doing, it determines the direction the parabola opens. A determines the direction And it also determines any stretches and shrinks. And I know I'm kind of writing small, but I hope you can kind of see that. H. Hope you guys are surviving that weekend snow apocalypse that was supposed to come and nothing really ever came besides, I guess, Sunday morning. So hope you all survived that and no one crashed into any telephone poles. So, and if you think about what H did over here, what was this -2 doing? It controlled horizontal translation. And if you think about K right here, what did K? That controlled vertical translation. So all of this is still within that same, you know how to do all this just based on this, but we're just kind of creating this form of it now called Vertex Form. Okay, so we're actually, our first step is what we want to do is we actually want to graph stuff in Vertex Form. So looking at this, f of x equals x minus 4 squared plus 3. So the first thing that you've noticed is that we know what the vertex is now just based on this. Now, we really didn't discuss that before. And again, some of you would know how to even start this because you know the parent function is x squared. So most of you would even know, okay, I need to go, this is telling me to go up 3. This is telling me to go right 4. So I go up 3, right 4. And that will actually lead me to my vertex. Well, now I just want you to have the ability to look at this and say, okay, the vertex is 4, 3. Now you may be saying, no, I thought you said it's this. This is the, that would be the H, and this would be the K. But keep in mind, if you look back at this formula, it's always, it's minus H, okay? So it's the opposite of H, so your vertex is always going to be opposite of whatever this is right here. And that the reasoning behind that is because we go right here. So it's always going to be opposite of this. So notice here, my vertex, I put +4, not -4, because it's always opposite of whatever's here. So I can say here, adding to my notes here, is that the vertex is always going to be H, K. It's not going to be this minus included. It's just going to be whatever H is, okay, or the opposite of H. So now I can write that down, 4, 3. I can put a point there. Now, something else that I want to bring out is what we call the axis of symmetry. The axis of symmetry is basically whatever the vertex is, because if you think about a vertex is where these 2 points are meeting, this parabola is meeting, it's actually the axis of symmetry, or the line of reflection as a more probably elementary term. So I'm just going to draw a line here on my vertex. As you see there, put some lines, and I'm actually going to say that's AOS, or axis of symmetry. So my axis of symmetry is x equals 4. That's going to help me find these points much easier than I found them before. Now, here's where, when we're graphing these in vertex form, which is very similar to what we've done before, but we just didn't know that this was actually the vertex, and we could think about the axis of symmetry this way. I think I briefly mentioned it, but now we know where the vertex is automatically just by looking at these two. Now we're just kind of do what we did before. If you think about this, that whole x minus 4 squared plus 3, well, we've taken care of this. We've taken care of this, so now what we have is just an x squared. So from our vertex, we just need to graph x squared. This is where I told you, you need to know your coordinate points for these parent functions. So if you can remember, now notice this graph, it goes by halves, so be careful there. But a x squared graph looks like this, right 1 and up 1. Because if you put a 1 into here, so if this is f of x equals x squared, if you put a 1 in there, you're going to get f of x, or y, is 1. So it's almost like a x, y table, and y and f of x is the same thing. If you put a 1 in, you're going to get out a 1 from this point here, okay? Now, what's cool about the axis of symmetry is you just got to go on this side, since it's going half, a half 1, or a half 1, so basically it's 1 coordinate from that side. And that's what that line of reflection does. So we don't have to find all these points over here. We can just use the line of reflection once we find points on either side. Well, the same way with if you're thinking about x squared. So if I put a 2 in there, 2 would be 4. So from the vertex, write 2, 1, 2, and then up 4. 1, 2, 3, 4. And keep in mind those are half increments. And then likewise, I can go 1, 2 on, from the line of reflection. So go 1, 2 from the axis of symmetry here. And then now we're creating our parabola, as you know. So it should look something like that. All right, going to the next one. Give you just a second to get that down. And again, hey, anytime you need to pause the video, pause it. Do whatever you have to do to kind of keep the flow of the class pretty smooth. Make sure you're being respectful to Mr. Scenarius as well. So f of x equals 2 times x plus 3 squared plus 2. So again, what's my vertex? Well, I should know my vertex just from looking at this right here. -3. It's opposite of this every single time, 2. So I got -3, 2 is my vertex. I can put that point there. And then in addition, I want to see this. I want to see this even to all you geniuses out there who know how to do this already. Or you saw the first one, so then now you're good for the rest of the day. I want to see this axis of symmetry line. So I want you saying the axis of symmetry is x equals -3. So your axis of symmetry will always be your x coordinate of your vertex. Okay? Keep that, and then with that in mind, now we would just want to graph it. So keep in mind that if you think about this, 2 times x plus 3 squared plus 2, we've taken care of the vertex. That's plus 3 and plus 2. So we're really just left with this 2x squared. Well, if you're looking at this right here, if you put a 1 in, you're always going to, if you put a 1 in there, you're going to end up with whatever's here. So an easy way to always think about this is if I go 1 from this at any time, I can just follow whatever this is. So I can go right 1, then whatever that number is, I can go right 1 and up 2. Using my axis of symmetry, I can go over here and put a point on that side of the axis of symmetry. So shortcut, what we're saying here is whatever A is, so going back up to here, whatever this A is, you can go right or left, and whatever A is, you need to go up if it's positive, down if it's negative. So look over here, A was 1, so notice we went right 1 and up 1, left 1 and up 1. Now to find that next coordinate point, you're going to have to look at, you have to put another number in here. Put 2. Well, 2 times 2 squared is 2 times 4, and that's 8. So from your vertex, you're going to go right 2, 1, 2, and up 8. 1, 2, 3, 4, 5, 6, 7, 8. See, I only have to find one point now because I can come over here and say 1, 2, 1, 2. And then I have my parabola. If you hear those footsteps walking around, that's my dog just kind of walking around. He's tripping because of all the snow outside, so he's wanting to go play. So looking at, that's just a kind of disclaimer there. I know it probably sounded a little bit awkward, but if you hear like small footsteps, I don't want you to think, I got demons running around my house. Those are actually that's Rocket. Rocket, come here, boys. Here's a boys. I'll show you Rocket real quick. So this is Rocket. Rocket, sit. Sit. Hey, boys. Sit. Oh, yeah, good boys. Good boys. Okay, so that's your advertisement. That's brought to you by Geico Insurance, providing you and saving you 15% on car insurance. So that's brought to you, that little advertisement is brought to you by Geico Insurance. Better way to save. Okay, so that is that graph. Going to number 3 now. So if I'm looking at 3, again, start with my vertex. What is my vertex? My vertex is the opposite of this, 3, and whatever this is, that's just normal, whatever it's going to be. 3, -2, so I can go 3, -2, put my point. And now, again, draw that axis of symmetry. Our axis of symmetry is x equals 3, whatever that is. And hey, it doesn't have to be a dashed line. I'm okay if it's a solid line. Just label what it is. Axis of symmetry. Give you a second to get that. So now if you listen to what I just said about A, anytime you go left or right from here one time, just follow A. So if we go right 1, we can go down 2 because A will tell you what if you. It only works. It's a little shortcut when you just go left or right 1. So if I go right 1 and down 2, and then likewise I can put that over here as well. So I'm beginning to see the form of my parabola. I just need to get one more point. So like I can just say. Again, there's a couple different ways I can do this. I can do this as if saying like, oh, that's gone and that's gone and that's gone. Or I could even just say, like, write the whole thing down. -2 times x minus 3 squared minus 2. Now I'm going to pick a smaller number like on this side because as long as I get 1, I can get 5 because it's the same distance. So watch, -2 times, I'm going to use 1 minus 3 squared minus 2. So what I'm trying to find is what is y. I'm basically making an xy table here. What is y when x is 1? Well, I just put it into the original. Again, there's a million different ways to kind of work this. So you got -2 times 1 minus 3. 1 minus 3 would be -2 squared minus 2. And then you'd have -2 times +4 because -2 squared is 4. And then you got that -2. So then that would lead you to -8 minus 2. -8 minus 2 is -6. So when x is 1, y is -6. Oh, excuse me, not -6. See, I told you I'd make mistakes. See, there's somebody in every class in Algebra 2 right now that are screaming, no, not -6, it's -10. I was about to say it kind of looked weird there, so it's actually 1 -10. See, this keeps you on your feet to make sure you're paying attention. So 1 -10. And then like I said, since we have our line of reflection, it's 2 from there, so go 1, 2 from there. And we have that right there. So then we just graph here. And then we have that. Briefly looking at 4, so I hope you're kind of seeing this or the process, and if someone needs to kind of explain a little further, you can pause the video and say, hey, you know, this is another way you can look at it. Again, I'm not so prideful that I'm sure you all see different ways to kind of see this. Don't be so arrogant like, oh yeah, this is so much better, you know, whatever. But, you know, if you see something, if someone's struggling, you know, help them out a little bit. So the vertex, I'm going to work through this one very quickly. Our vertex is 2, -2. Again, it's always opposite h and then k. Again, if you're thinking about that, if we're going back here, it's always opposite h, k. So if you're looking at it, it's opposite h, k. And then what is my axis of symmetry? Well, my axis of symmetry is x equals whatever this is, 2. So I got to point at 2, -2, 2 negative. Sorry, I had a little lapse with my video there, but so we had that point at 2, -2, and then I went ahead and drew my axis of symmetry line. And then if you can recall that shortcut that I shared with you, whatever A is, just go right from there and then follow that. So it's actually right 1, down 1. And keep in mind, these are half increments, so you actually go right, it's like a half and then 1. Right 1, down 1. And then likewise over here, left 1, down 1. So you can just follow A every single time and just do what it's kind of telling you. So as you see here, this is just simply x squared. So it's 1 and 1, but then the next point would be, if you know what x squared is, that negative is actually flipping it down, a reflection. So if you know, you should know your points for x squared, it's 1, 1, 2, 4. So you can go right 2, 1, 2, and then down 4, 1, 2, 3, and 4. And then likewise over here, left 2, 1, 2, and down 1, 2, 3, and 4. Okay? So this is very similar to what we've been doing, but it's just in this more particular, what we call vertex form. Okay? Going to the back side now, I'll give you, make sure you got that. And like I said, anytime, pause the video. That's that. Going to the back side, use the information provided to write the vertex form equation of each parabola. So here's kind of where we want to start. Here's what we know. We want it in vertex form. Keep in mind that vertex form is this. F of x is equal to a times x minus h squared plus k. So that is what vertex form is, and it just wants us to write this graph in that form. So to do that, first thing we need to do is to find the vertex. Okay, well the vertex here is 6, negative 3. So I'm going to say my vertex is 6, negative 3. All right. So for each one of these, what I would do is I would just simply write out f of x. I'd write out my formula. I just kind of wrote that for the top of the paper. F of x is equal to a times x minus h squared plus k. Well, we already know what h and what k are. So we just substitute those in. So this becomes f of x is equal to a times x. H is, it's 6 here, so obviously down here it's going to be the opposite, negative 6. So just bring down the minus and just say that's h squared minus 3. Because whatever you're just replacing, you're just substituting negative 3 for k. Well, that gives us literally everything we need except a. Okay? So, and a kind of tells us what is it doing. Is it being stretched? Is it being shrunk? Is it reflected? Well, you can kind of look at the graph and determine that. And many of you are going to look at that graph and say, oh, okay, that's if this is the vertex, it's going left 1 and up 1, left 2 and up 1, 2, 3, 4. Oh, that's just x squared, so a should be 1. And I know some of you see that way. But just in case, here's what I want you to do. I want you to pick a point. So I'm going to write that over here. Pick a point that you can read. Okay? So if you can see it based on the graph, that's great. Okay? This would just be a normal x squared graph here. So I know that this a is going to be 1, but I'm going to prove it mathematically. And this is maybe the way that most of us have to do this. So I'm going to pick a point that I can read. Well, this point right here is just kind of sticking out here to me, and that's 4, 1. 4, 1. So knowing this is 4, 1, and this point is a part of this graph, which is a part of this equation, I know this is x and this is y. And y is also the same thing as f of x. So what I can actually do here is I can actually substitute these values in. It's a point on the graph. I can substitute them in right here and say my f of x is 1 equals a times x. X is 4 minus 6 squared minus 3. Now what you notice is that I only have one variable that doesn't have anything. I've filled in the y or the f of x, and I've filled in the x. So anytime you have everything but one variable, you can just solve for the variable. So just solve for a. So 1 equals a, and then I'll always do parentheses. 4 minus 6 is what? Negative 2 squared minus 3. Well, that's 1 equals a times negative 2 squared is 4 minus 3. How can we rewrite a times 4? Well, we can rewrite a times 4 as just simply 4a. Because it's just being multiplied, so we can write it, take the parentheses out, write 4a, and then minus 3. Here, we're going to add 3 to both sides. That cancels, leaving me with 4 equals 4a. Divide both sides by 4, and you see that we get a is equal to 1. So now that I know a is 1, I can now write my f of x out, the equation for this graph. F of x is equal to, technically I can write a 1, but I don't have to because we know 1 times this is just simply just going to be it. So we can just simply say here, x minus 6 squared minus 3. And that's what I'm looking for right there. And keep in mind though, and the reason that I said we know this is going to be 1 from the beginning, because we can look at the coordinate points and we can say, okay, this hadn't been stretched. It's just your normal x squared graph. Left 1 up 1, left 2 up 4. So there's kind of shortcuts you can do. But if it does appear like it's been stretched, as number 6 does, and number 8 and number 7, they appear like they're not a normal x squared graph. So well, I think maybe number 6 may still be normal because it looks a little bit different because it's half increments, and we can kind of go from there. But we know it's not just 1, and we'll kind of get to that. So you just follow that method of picking a point, putting it in there, and then you're going to solve for A, and then that'll give you this A. So technically we could put like a 1 right there if we wanted to, but we don't have to. That's why we solve for A, to find A there, but as you see, it's just 1. Going to number 6 real quick. So number 6, if I'm looking at number 6, start off with my vertex. Well, what is my vertex? My vertex here is -4. Make sure I read this right. -4, 3. -4, comma, or not 3, excuse me, 2. 1, 2, because they're going by half increments. Now I'm going to write my formula. F of x is equal to a times x minus h squared plus k. Well, substitute in now. F of x is equal to a, I don't know what a is, x minus h, so that minus there should be plus 4, because if I put minus -4, that's just going to turn to a plus, and again, it's always opposite of that, squared, and then it's just always whatever that is normally, so plus 2. So I have it, but the only thing I need is what has happened to it. Has it been stretched? Has it been shrunk? Has it been reflected or anything? And that's what A determines. Well, I can see that it's obviously been reflected down because x squared, if you know, it looks like that. So I know it's been flipped down, so this has to have a negative, but we can see if it's been stretched. And again, some of you can do that based on the points, but other people, we just need to pick a point. So I'm going to pick this point right here that I can read. And when I say, let me zoom in and kind of show you what I mean. Like when I read, for instance, I can't really read this point right here, but I can read this point a lot clearer. So looking at that, I know I got a point at -3 and 1. So that's x and that's y. And keep in mind, y and f of x are the same. So f of x is 1. I'm going to substitute it in. Equals a, which is what I'm looking for. Now substituting my x from the point. This is a point on the graph, so it's a point in the equation as well. That's the method of finding a. And -3 plus 4 squared plus 2. So you get 1 is equal to a. -3 plus 4 would be 1 squared plus 2. And then you get 1 equals, well, 1 squared is just 1. So that's a times 1 plus 2. And how can I write a times 1? Well, that's just simply anything times 1 is itself. So that's just simply a plus 2. And then I'm just going to subtract 2 from both sides in order to isolate a. You all know how to work equations. A equals -1. So it hadn't been stretched. It hadn't been shrunk. It just equals -1. So that means we're going to have f of x equals a is -1 or just simply negative. And then you're just going to come up here and rewrite that out. X plus 4 squared plus 2. So all this work right here, the only thing it's doing is it's getting us a, so we can put it here. We're basically almost done when we get to this second line here, but we just got to find a, and picking a point and plugging it in and then solving for a is what allows us to find a here. Okay, going to number 7. So with number 7, same thing. Let's start. What is my vertex? Well, my vertex is -5, 0. Well, my vertex is -5, 0, so what I'm going to simply do here is I'm going to write my formula. F of x is equal to a times x minus h squared plus k. We need to know that formula. What is that? Vertex form. So here we have f of x, and we can plug in our vertex now. So we got a and then x, and then what we can say here is it's opposite of that, so it's going to be +5. And then k is just simply going to be squared. And then we can say +0 just so we can kind of see that form. So once we have our vertex, we got our formula written out. Now we just need to go find another point on the graph that we can read. It doesn't matter what point that is. I'm simply going to pick this point right here, -3, 2. I'm going to write that kind of big, -3, 2. here is my x, here is my y, and keep in mind that y and f of x is the same thing. Y is just, f of x is just meaning function, which is very similar to the equation y. So now let's substitute this in, because we got our vertex, but now the only thing we need to do is to find a by picking a point and plugging it in. So f of x is 2 equals a, I don't know. X is -3 plus 5 squared. And we don't really have to say plus 0 here, because we know anything plus 0 is just going to be itself. So now I can work this out. 2 equals a. -3 plus 5 is +2 squared. And then 2 equals a times 4. Keep in mind, a times 4 is the same as 4 times a, or just simply 4a. We divide both sides by 4. And we get a is equal to 1/2. So now we rewrite our equation. We're going to say f of x is equal to 1/2 times, and then just go back up here to this line right here, and you can just copy that down, times x plus 5, that's our vertex, right, squared, and then I don't have to say plus 0. That's what we're looking for right there. And I think you kind of get that for that point, as far as I think I hope you're getting it. So going on to number 9. So what about when we don't have a graph and it just gives us the vertex and the y-intercept? Well, in that case, write our formula. F of x is equal to a times x minus h squared plus k. Well, here's h and here's k. So let's just punch it in. F of x is equal to a times x, and this is going to be opposite, so it's not 2, it's -2 squared minus 5. And we could say plus minus 5, but that's the same thing as just simply minus 5. Now, here's the difference. Notice when we got to this point last time and we need to find a, we found another point. Well, it didn't give us a graph to find another point, but it did give us the y-intercept. And you may be saying, well, that's just one point, but keep in mind the y-intercept, when x is 0, then you're going to have your y-intercept. So technically, this point is actually telling us it's 0, -9. So we actually do have a point, and what we can do is we can substitute that in now, kind of following that same pattern. So it's just interpreting that this is 0, -9. So I can now punch this in, that's x, and this is f of x, or it's just simply y. So -9 is equal to a, and then x is 0 minus 2 squared minus 5. Then from there, we can say -9 is equal to a, and that's going to be -2 squared minus 5. Now I'm going to take this up here now and say -a, and I'm going to go ahead and solve some. -9 equals a, -2 squared, we know it's 4, and then that minus 5. Keep in mind these are being multiplied though, so I can rewrite it as -9 equals 4a minus 5. We're going to add 5 to both sides and get -4 equals 4a. And we get a is equal to -1. So my final equation here would be f of x equals my a, which is now -1, times whatever's right here. X minus 2 squared minus 5. And this would be my answer. Or I don't have to include the -1. I can just say negative times all that, and that works as well. Last one will work is number 11. So if I'm looking at number 11, same thing. I got my formula. F of x is equal to a times x minus h squared plus k. Again, they just want you to interpret that this right here is actually 0, -52. I don't have a clue what I was thinking when I put a y-intercept of negative. Whoa, look at number 12. negative 1,542. I don't have a clue what happened there. So within this, now we're going to substitute everything in. Or we can go ahead and, let's go ahead and substitute our h and k in first. So that's f of x is equal to a times x. It's opposite of that. So minus 4 squared and then minus 4. We have our point here. That's our x and that's our y, or our f and x, whatever you want to call it. So once we type in our formula, or once we punch in our vertex into our formula, now we can punch in the coordinate point that it gives us in order to solve for a. So y is negative 52. A is what we're looking for. X is 0 minus 4 squared minus 4. So that's negative 52 equals a. 0 minus 4 is negative 4 squared minus 4, right? Well, that takes us to negative 52 equals a times 16 minus 4. And now if we rewrite that, that would look like this. Negative 52 equals 16a. Notice I just said from a times 16 is 16a minus 4. Then I'm going to add 4 to both sides. And I'm going to cancel that. That's going to lead me to negative 48 equals 16a. And then you divide both sides by 16. And you're going to get a to be negative 3. And it's okay. I don't know how big of a number I had, but it's okay if you need to divide 48 divided by 16 on your calculator, whatever. And you get 3 there. So negative 3 because it's a negative divided by a positive. So then we can write our formula as f of x is equal to negative 3, which is a, then times x, and then, like I said, it's just copying that down. X minus 4 squared, because that was our vertex. And that would be our answer. Hey, I hope that made sense today. If you need to reach out with somebody else, that's cool. But I hope you have a good day. So, paper people, you can go ahead and pass out lesson 2.1 homework. Go ahead and pass that out. And then again, you're holding all that until I get back on Monday. Hey, have a good day, guys.